Hi, I'm Thorsten. I've been fiddling with computers since I was 11. Today I'll show you how easy it is to modify a program even after it has been compiled. This can be a real eye-opener when it comes to software security, assembly, and machine code. I already made a similar video using Linux, but today we are diving into Windows. You see, in programming, you usually start with a source code file that you translate into machine language, and you call this step compiling. Let's have a look at a typical source code file, in this case, hello.c. It does nothing but print out hello world. And this we now want to make executable. In other words, we want to translate it into machine language. In other words, we want to compile it. This is quite easy because I have installed the MinGW compiler from the GNU project. So I go to Open in Terminal, do a short dir. So yes, hello.c is available. I do a type hello.c, and we see it indeed has still the same content. So I say GCC like GNU compiler collection or GNU C compiler, whatever you prefer, -o for output, hello, hello.c, enter. And now let's have a look. We have a new file called hello.exe, and this file is hopefully executable. So I call it hello.exe, and it does exactly what it is supposed to do, namely print hello world. Not bad. So let's have a look at the machine code. I say notepad hello.exe, and I get disappointed because there's a lot of stuff that I cannot really read. Yeah, here are question marks. That means this is a byte the computer does not know, another byte the computer does not know, and we don't even know if these are the same bytes. So, catastrophe, that is not the way how you look at binary code. How do you look at binary code? You use a hex editor. And for this, I installed hxd hello.exe. And now you see something indeed beautiful. Because on the right side here, so this window here, or this part here, the dark blue part, there you see the human readable characters. And here you see each byte in its hexadecimal notation. So if there is a byte that cannot be written in human readable notation, then it puts a dot here. So if you see a dot here, it can be either a dot or a non-writable character. So by this, you can, for each, you can find out what byte you have. And now let's just search for it and find and replace it. Let's search for a text string, which is hello. And now here we see hello world. And let's just replace this. Sorry, go here. And instead of hello world, we write hi moon. And then we make some exclamation marks to fill it. And in C, strings are being terminated by 0 bytes, which is exactly the case here. This here is a 0 byte. And we save this now and close it and call the program again. And we see we have overwritten it from hello world to hi moon. Okay, so we did a change even after we have compiled it, and we did not modify the source code. So this can be now a real security concern, because imagine you have these programs on your disk and someone and maybe they have a security warning that a hacker attack is coming, and the hacker just goes and overwrites this by something else. So this is quite a security concern. But we can look deeper into this. And to look deeper into this, I have installed the program x32dbg under Windows, and I use it to debug hello.exe. So it looks like this. Will load now. Will it load now? Okay, so I open again hello and hello exe, I open again. And now I make the window a bit smaller. So you see here, we have the test output. And when I now say here, run this program, you will see that it, after finally kicking off, it will write hi moon here. So let's start from the beginning here. The cool thing is here you have the address of the bytes of the first byte that you see here. Here you see the typical machine code gibberish, in this case EB07. You may ask, why is this now not the beginning of our exe file? Well found, yeah, because we are in the file ntdll.dll, so that is the DLL loader of Windows NT. It first makes sure all constants and libraries are put into their right place. So once our program starts, it can really start and find everything there where it expects it to be. So we have here the address of the byte. Here we have the addresses. So the machine code, the first machine code command has 2 bytes, EB and 07. And here to the right, we have something that is very interesting. Here we have the assembler code. Assembler is a programming language that a human person can read, because if you think EB07, you don't know what that command does. But if you translate it into assembler, you will know it, because JMP means jump. So this is a jump command. This means you move your instruction pointer somewhere else. Then the other thing you need to know is that, how a processor really works. So we have a processor. And this thing is doing nothing else but having some registers. And one register is IP, extended register instruction pointer. And this is where the processor goes to that memory address, gets what's there, and executes it. That's what the processor does all the time. The processor has also some other registers, like extended register A, X, and B, and C, and D. And it can use these to calculate things. You know, a computer has a processor and a huge amount of memory. In this memory, you cannot do calculations. If you want to do an addition, the only way you do it is by the processor fetching the data from the RAM into its registers, performing the operation, for example, adding 1, and then storing back the data into the RAM. This is how a processor works. And so we now see this is the first thing. It is a jump. So what will happen? It will jump to this address here. So we click on step into. That means we want to do a single step. We could also do a step over. In this case, there would not be a difference. So let's call this. Jump has worked. It is now doing a MOV operation. In other words, it is fiddling around with memory. And it is all the time in the NT DLL loader. So I say, let's go to the user code. And now we are finally in the user code. And if you have a look at our program, you will see that this is the beginning of one procedure. So to do this, we use the command objdump. We have this command because we have installed MinGW. So objdump -d like disassemble, -m like machine architecture, Intel. So we want to have this in Intel syntax displayed. And what is it what we want to have in Intel syntax displayed? It is hello.exe. And now we see the disassembly of all our program. So we have it here. The hello.exe is in machine code. Objdump translates it into assembler. And again, here you have the address, here you have the bytes, and here you have the code in an almost human understandable language, which is called assembler. Okay, and now that we have done this disassembly, we redirect it to test.txt, and then we can have a look at it. Notepad test.txt, and well, I'm keeping this now. A bit small because I need to just make it small, and then I go back to the debugging program, and I find it. Okay, we have, what do we have here? We have 56. We have 3D 64, and I want to find this right here in the program. And so I say edit, find. Not so easy with the small screen. Find. And what I want to find is A3 EC14, and then we see this is in the middle of a program, so this cannot be it. So let's go to the next one. Here we see the beginning of the procedure dyn tls init. This is from our program. It is no longer from the NT-DLL loader. So we have here first byte is 56. Here the first byte is 56. Second byte is 53. Here the second byte is 53. Then we have A3 EC14, just like here. So this is where really our program starts. And here we can debug it step by step and look for each command in machine language, what happens in the registers. And then if we want, we can go into an hex editor and edit it here. For example, it is easy to override commands with 90 hexadecimal, which means no operation in Intel x32 syntax. And by this, we can not only override hello world with hi moon or something like this, but we can really change the program flow. And I want to encourage you to have a look have a look into this debugger, because it's that interesting how complex it is to even write hello world onto your console. Many thanks for your attention, and I'm looking forward to any comments that you may have.